Hello, in this lecture we will find out the values of line segments x and y. In the drawing we have a square DEBF, and the square is inside the right triangle ABC. You know that one side of square BDEF is equal to 1 unit, and all the sides of a square are equal to each other, therefore DE equals also to 1 unit and EF also equals to 1 unit. And we also know that the hypotenuse AC of the right triangle ABC equals to 3 units. And we want to find out the values of line segment FC, that is actually equals to x, and the value of line segment AD that equals to y. Okay, so first of all, we know that the opposite sides of a square are parallel to each other. That is to say, DE is parallel to BF, I'll repeat it again. The opposite sides of a square are parallel to each other. That is to say, DE is parallel to BF, and we also know that BC is one side of the right triangle ABC. Therefore, BC is a straight line, I will repeat again. BC is a straight line, and BF is part of the straight line BC, and BF is parallel to DE. So we know that part of the straight line BC is parallel to DE, and because of the fact that part of the straight line BC is parallel to DE, then the straight line itself BC will be also parallel to DE. Okay, so BC also parallel to DE. Okay, according to our conclusion, the straight line BC also parallel to DE because of the fact that if a part of a straight line is parallel to another straight line, then the straight line itself will be also parallel to that straight line. Okay? And we have also rule number 1. According to rule number 1, corresponding areas between parallel lines are equal to each other. I'll repeat again on rule number 1. According to rule number 1, corresponding angles between parallel lines are equal to each other. So actually those two angles are defined as corresponding angles, that is to say angle AED and angle ECF are defined as corresponding angles, and they are located between the parallel lines DE and BC, that is to say DE is parallel to BC. Therefore, those two corresponding angles are equal to each other. So we can write down that angle AEC this angle is equal to angle ECF, this angle, and they are equal to each other according to rule number 1. I'll repeat again. Angle AEC is equal to angle ECF according to rule number 1. It's actually angle AED. This angle is angle AED, and angle AED equals to angle ECF. Those two angles are equal to each other according to rule number 1. And if we define angle AED as theta, if angle AED will be defined as theta, then from this equation theta equals to angle AED equals to angle ECF, we will conclude that angle ECF also equals to theta. So angle ECF also equals to theta. So those two angles, they are equal to each other, they are both equal to theta. And we also have another rule, rule number 2. According to rule number 2, the sum of the angles on one side of a straight line is equal to 180 degrees. I will write it down. The sum of the angles on one side of a straight line is equal to 180 degrees. I will read rule number 2 again. According to rule number 2, the sum of the angles on one side of a straight line is equal to 180 degrees. And AB is one side of the right triangle, triangle ABC, therefore AB is absolutely a straight line. AB is a straight line. As one side of a triangle, it must be a straight line. So AB is a straight line. I repeat again, AB is a straight line. So if we focus on this side of the straight line AB at point D, then the sum of the angles must be equal to 180 degrees. And if we define angle ADE as angle X, then angle X plus this angle that is 90 degrees must be equal to 180 degrees according to rule number 2. Angle X plus the right angle must be equal to 180 degrees according to rule number 2. So here we will subtract 90 degrees from this equation and we get that angle X equals to 180 degrees minus 90 degrees is 90 degrees. So we found out that angle X is a right angle, it equals to 90 degrees. So we can substitute angle X by right angle. Likewise, BC is one side of the straight line of the right triangle. BC is one side of the right triangle ABC, therefore it is absolutely a straight line. So we can write down that BC is a straight line also. BC is a straight line. And if we focus on the upper side of the straight line BC at point F, then the sum of the angles at point F at the upper side must be equal to 180 degrees. So if we define angle EFC, this angle is angle Y, then we get that according to rule number 2, angle Y plus this angle that is a right angle, that is to say it equals to 90 degrees. So the sum of those two angles must be equal to 180 degrees according to rule number 2. I will repeat again, angle Y plus the angle that equals to 90 degrees must be equal in total to 180 degrees. Here we subtract 90 degrees from this equation and we get that angle Y equals to 180 degrees minus 90 degrees is 90 degrees. So angle Y is the right angle, that is to say it equals to 90 degrees. So we substitute angle Y by right angle. In the next step, we will focus on the right triangle AED. On the right triangle AED, tangent theta equals to AD over DE. I repeat again, on the right triangle AED, we know the tangent theta equals to AD over DE. But AD equals to Y according to what is given us in the question. And DE equals to 1 unit. So in conclusion, according to equation number 1, tangent theta equals to Y I repeat again. In conclusion, according to equation number 1, that tangent theta equals to Y. In the next step, we will focus on the right triangle ECF. On the right triangle ECF, tangent theta will be equal to EF over FC. I'll repeat again. In the right triangle EFC, tangent theta equals to EF over FC. But EF equals to 1 unit and FC equals to X according to what is given us in the question. So in conclusion, according to equation number 2, tangent theta equals to 1 over X. I repeat again, according to equation number 2, tangent theta equals to 1 over X. And according to equation number 1, tangent theta equals to Y. So we create equation number 3 that states that tangent theta according to equation number 1 must be equal to tangent theta according to equation number 2. Okay. Equation number 3 states that tangent theta according to equation number 1 that equals to Y must be equal to tangent theta according to equation number 2 that equals to 1 over X. So in conclusion, we found out that according to equation number 3, tangent theta equals to 1 over X. And if we multiply equation number 3 by X, we get that according to equation number 3, Y times X equals to 1. And whenever the multiplication of two numbers is equal to 1, it means that X is the inverse number of Y, and also Y is the inverse number of X. So I will write it down. We actually found out that X is the inverse number of Y, and it is also true to say that Y is the inverse number of x. And we have a rule that states that every number has only one inverse number. So I write down the rule. The rule states that every number has only one inverse number. So the inverse number of 5 is 1 over 5 and only 1 over 5. And the inverse number of 1 over 5 is 5 and only 5. Okay, in the next step we will focus on the right triangle, right big triangle, triangle ABC. On the right big triangle, triangle ABC, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in the right triangle ABC is AC. The square of the hypotenuse is AC squared. And it equals to the sum of the squares of the perpendiculars, that is to say it equals to AB squared plus BC squared. So, I repeat again, in the right triangle, triangle ABC, according to the Pythagoras theorem, here PT is the abbreviation for Pythagoras theorem. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars, that is to say AC squared equals to AB squared plus BC squared. So according to equation number 4, AC squared, AC equals to 3 units according to what is given as the equation. Therefore AC squared will be equal to 3 squared. 3 squared is 9. And 9 equals to AB squared. AB equals to y plus 1. Therefore AB squared will be equal to y plus 1 squared. Plus BC squared. BC equals to x plus 1, therefore BC squared will be equal to x plus 1 squared. So, in conclusion, we found out that according to equation number 4, 9 equals to y plus 1 squared plus x plus 1 squared. Here we will open the brackets on this side of equation number 4 and we will get that according to equation number 4, y plus 1 squared equals to y squared plus 2y plus 1 plus x plus 1 square, x plus 1 square equals to x square plus 2x plus 1, and it equals to 9. So according to equation number 4, y squared plus 2y plus 1 plus x squared plus 2x plus 1 equals to 9. But according to equation number 3, we already found out that y equals to 1 over x. Therefore, we can substitute y by 1 over x in equation number 4, and we will get that according to equation number 4, y squared is 1 over x squared plus 2y is plus 2 times 1 over x plus 1 plus x squared plus 2x plus 1 equals to 9. Here we will organize the expression in equation number 4 in a different way, and we will get that according to equation number 4, x squared plus 1 over x squared (1 plus 1 is 2, so it is plus 2) plus 2x plus 2 times 1 over x equals to 9. So here the expression inside the brackets x squared plus 1 over x plus 2 equals to x plus 1 squared, x plus 1 over x squared. So I'll write it down. And here we have 2x plus 2 over x. Here we'll take 2 as a common factor out of these two expressions, and we'll get inside the brackets we will have x plus 1 over x equals to 9. Here we will define x plus 1 over x as t, that is to say t equals to x plus 1 over x according to our definition. In the next step we will substitute x plus 1 over x in equation number 4 by t, and we will get that according to equation number 4, here we have x plus 1 x squared is t squared plus 2 times x plus 1 over x is 2t. Here we subtract 9 from this equation, equation number 4. So it is minus 9 equals to 0. So here we got a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0, when a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for, and we will find out the value of x according to a special formula. X actually equals to minus b plus minus square root of b squared minus 4 times a times c over 2a in our specific quadratic equation, t squared plus 2t minus t equals to 0, the variable that we are looking for is t. So we can write down that x equals to t, and the coefficients of this quadratic equation are as follows: a equals to 1, b equals to 2, and c equals to minus 9. So the only thing that is left to do is to put the data inside the equation for x, and we'll find out the value of x that in our case is t. So x equals to t, so it means that t equals to minus b. B is 2, so minus b is minus 2, plus minus square root of b squared. B equals to 2, so b squared will be equal to 2 squared. 2 squared is 4, minus 4 times a times c. A equals to 1, c equals to minus 9, so it is minus 4 times minus 9 is plus 36 over 2a. A is 1, so a is 2 times 1, 2 times 1 is 2. So here t equals to minus 2 plus minus 4 plus 36 is 40, so it is the square root of 40 over 2. So t equals to minus 2 plus minus 40 is 4 times 10, and the square root of 4 is 2. So in conclusion, we got here that t equals to minus 2 plus minus 2 times square root of 10 over 2. So here t equals to minus 2 over 2 is minus 1, plus minus 2 over 2 is 1, so we left here with square root of 10. So in conclusion, we found out that t equals to minus 2 plus minus square root of 10. So here we have actually two solutions that are possible for t. The first solution for t is t equals to minus 1 plus square root of 10. and the second solution for t is t equals to minus 1 minus square root of 10 and we'll focus on the solution, on the second solution, that t equals to minus 1 minus square root of 10. T, according to our definition, is x plus 1 over x, and it equals to minus 1 minus square root of 10 but from the domain you can see, from this domain you can see that x is length. X is length, is the length of a triangle, therefore it must be a positive number. So if x is a positive number, x plus 1x will be also a positive number. So in this side of the equation we have a positive number, and in the other side of the equation, in this side of the equation, we have minus 1 minus square root of 10 is a negative number. And because of the fact that a positive number can never be equal to a negative number, we got here a contradiction. Therefore, this solution is incorrect solution. So we cancel this solution, and we have only the solution that states that t equals to minus 1 plus square root of 10. This is the only solution that is possible for t. According to our definition, t equals to x plus 1 over x, and it equals to minus 1 plus square root of 10. Here we will multiply this equation by x, this side of the equation by x, and then we will divide it by x, and we will get that x squared plus 1 over x equals to minus 1 plus square root of 10 . Here we will multiply this equation by x, and we will get that x squared plus 1 equals to square root of 10 minus 1 times x. Here we will subtract square root of 10 minus 1 times x from this equation, and we get that here a quadratic equation. The quadratic equation that we will get is x squared minus square root of 10 minus 1 times x plus 1 equals to 0. So we have here a quadratic equation. The coefficients of this quadratic equation are as follows: a equals to 1, b equals to minus square root of 10 minus 1, and c equals to 1. And the general solution for a quadratic equation, we know that it is ax that equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. And in our specific quadratic equation, a equals to 1, b equals to minus square root of 10 minus 1, and c equals to 1. So we will put the data inside this equation, and we found out the value of the value for x, the value of the values of x, and we will get that in our specific quadratic equation x equals to minus b. Here we know that b equals to minus square root of 10 minus 1, and minus b will be equal to minus minus square root of 10 minus 1, that is to say it equals to square root of 10 minus 1, that is b, plus minus square root of b squared. So square root of b squared will be equal to square root of 10 minus 1 squared minus 4 times ac. A equals to 1, c equals to 1. So it is minus 4 times 1 times 1, that is to say it equals to minus 4 over 2a. A is 1, so 2 times a is 2 times 1, 2 times 1 is 2. So x equals to square root of 10 minus 1 plus minus, here square root of 10 minus 1 square, we will calculate the value of this expression according to the algebraic identity that a minus b square equals to a square plus b square minus 2 times ab. So here a is square root of 10, so a square is square root of 10 square, square root of 10 square is 10, plus b square, b is 1, so b square is 1 square is 1, minus 2 times a is square root of 10 times 1, minus 4, all divided by 2. So we actually got that x equals to square root of 10 minus 1 plus minus 10 plus 1 is 11, 11 minus 4 is 7. So inside the root we will have 7 minus 2 times square root of 10, all divided by 2. In the next step, we will present the expression inside the root that is actually 7 minus 2 times square root of 10 in a different way. We know that 7 is equal to 5 plus 2 minus 2 times square root of 10. we will substitute square root of 10 by square root of 5 times square root of 2, because of the fact that square root of 5 times square root of 2 equals to square root of 10. And it equals to square root of 5, it equals to 5 plus 2. So 5 is square root of 5. Square root of 5 equals to 5 plus square root of 2 plus 2, and 2 equals to square root of 2 minus 2 times square root of 2 times square root of 5. So the expression of square root of 5 square plus square root of 2 square minus 2 times square root of 5 times square root of 2 is very similar to the expression of a square plus b square minus 2 times ab, and according to the algebraic identity that a square plus b square minus 2 times a b equals to a minus b square, we get that this expression equals to a minus b squared, that is to say a is square root of 5 minus b is square root of 2 square. So we actually substituted this expression by a minus b square when a equals to square root of 5 and b equals to square root of 2. So in conclusion, we found out that this expression equals to square root of 5 minus square root of 2 square. And we actually found out that 7 minus 2 times square root of 10 equals to square root of 5 minus square root of 2 square. So we substitute 7 minus 2 times square root of 10, that is inside the root here, by square root of 5 minus square root of 2 square, and we will get that x equals to square root of 10 minus 1. So here we have plus minus, and I repeat again, we'll substitute 7 minus 2 times square root of 10 by square root of 5 minus square root of 2 square. And it is also, we have here minus 4 so it is all divided by 2, and we have here square root of 5 minus square root of 2 square and root. The square cancels the root, and we left only with square root of 5 minus square root of 2. So in conclusion, we found out that x equals to square root of 10 minus 1 plus minus, and again the square cancels the root, and we will left only with square root of 5 minus square root of 2, all divided by 2. So here we will have two solutions that are possible for x. We will define the first solution as x1 and the second solution as x2. So the first solution for x is x1, that equals to square root of 10 minus 1 plus square root of 5 minus square root of 2, and the second solution will be x2, all divided by 2 of course. The second solution will be x2 equals to square root of 10 minus 1 minus square root of 5 minus square root of 2, all divided by 2. So we continue with x1. Here x1 equals to, we'll substitute square root of 10 by square root of 5 times square root of 2 minus 1 plus square root of 5 minus square root of 2, all divided by 2. So x1 equals to, here we take square root of 5 as a common factor out of this expression. So square root of 5 is a common factor, and inside the brackets we will have here square root of 2 plus 1 minus, here we'll take minus 1 as a common factor out of these two expressions, and inside the brackets we will have square root of 2 plus 1, all divided by 2. So x1, here we take square root of 2 plus 1 as a common factor, and inside the brackets we will have square root of 5 minus 1, all divided by 2. Okay, we finished with x2. x2 actually, it is actually x1. x1, it is actually equals to square root of 2 plus 1 times square root of 2, square root of 2 plus 1 times square root of 5 minus 1 over 2. And we will do the same process for x2. Here we will get that x2 equals to, here we will substitute square root of 10 by square root of 5 times square root of 2 minus 1 minus square root of 5, and minus and minus is plus, so it will be plus square root of 2, all divided by 2. Here we take square root of 5 as a common factor out of this expression, and we'll get that square root of 5 is a common factor, and inside the brackets we will have square root of 2 minus 1, and here we will have also plus square root of 2 minus 1, all divided by 2. So we got that x2 equals to, we take square root of 2 minus 1 as a common factor out of this expression. So square root of 2 minus 1 is a common factor, and inside the brackets we will have square root of 5 plus 1, all divided by 2. So x2 equals to square root of 2 minus 1 times square root of 2 plus 1, all divided by 2. In the next step we will multiply x1 by x2, But first of all, I will copy x1 and x2 in a new page, and we will multiply x1 by x2, and we get that x1 equals to square root of 2 plus 1 times square root of 5 minus 1 divided by 2, and x2 equals to square root of 2 minus 1 times square root of 5 plus 1 all divided by 2. So here I copied x1 and x2 in this new page. Now we will multiply x1 by x2. So x1 times x2 will be equal to square root of 2 plus 1 times square root of 5 minus 1 divided by 2. So this is x1, and we have to multiply it by x2. x2 is square root of 2 minus 1 times square root of 5 plus 1 all divided by 2. So x1 times x2, here I will organize the expressions in a different way, and we'll get that x1 times x2 equals to square root of 2 plus 1 times square root of 2 minus 1 times square root of 5 plus 1 times square root of 5 minus 1 all divided by 2 plus 2 times 2. So here we'll find out the value of square root of 2 plus 1 times square root of 2 minus 1 according to the algebraic identity that states that a plus b times a minus b equals to a squared minus b squared. And in our specific expression, square root of 2 plus 1 times square root of 2 minus 1, a is equal to square root of 2 and b equals to 1. So this expression, square root of 2 plus 1 times square root of 2 minus 1, must be equal to a squared minus b squared. And here a equals to square root of 2, so a squared is square root of 2 squared, square root of 2 squared is 2 minus b squared. B equals to 1, so b squared is 1 squared, 1 squared is 1, so minus b squared is minus 1. So in conclusion, we found out that square root of 2 plus 1 times square root of 2 minus 1 equals to 2 minus 1, that is actually 1. In the same way, we will calculate the expression of square root of 5 plus 1 times square root of 5 minus 1. Here a equals to square root of 5 and b equals to 1. And this expression, according to this algebraic identity, must be equal to a squared minus b squared. A equals to 5. Therefore, a equals to square root of 5. So a squared will be equal to square root of 5 squared. and square root of 5 squared is 5 minus b squared. B equals to 1, so b squared is 1 squared, 1 squared is 1, so minus b squared is minus 1. So in conclusion, we found out that this expression, square root of 5 plus 1 times square root of 5 minus 1 equals to 5 minus 1. So we found out actually that x1 times x2 equals to 2 minus 1 times 5 minus 1 all divided by 2 times 2. 2 minus 1 is 1, 5 minus 1 is 4, all divided by 2 times 2 is 4. 1 times 4 is 4, and 4 over 4 is 1. So, in conclusion, we found out that x1 times x2 equals to 1. I will write it here again. We actually found out that x1 times x2 equals to 1. We found out that x1 times x2 equals to 1. What does it mean? It means that x1 is the inverse number of x2, and it is also true to say that x2 is the inverse number of x1. Okay, I'll repeat again. According to the equation x1 times x2 equals to 1, we will derive from it, we will conclude from it that x1 is the inverse number of x2, and also x2 is the inverse number of x1. But according to equation number 3, we have already found out that x times y equals to 1. Here we can also conclude that x is the inverse number of y and y is the inverse number of x. But if we put the two solutions that are possible for x and y inside this equation number 3, we get that the first solution that is possible for x and y is x1, y1. So we will put the solution inside the equation number 3, that is to say x1 will be equal to x will be equal to x1 and y will be equal to y1, and we get that x1 times y1 equals to 1. What does this equation means? X1 times y1 equals to 1. It means that y1 is the inverse number of x1. Okay, y1 is the inverse number of x1. But we have already found here that x2 is the inverse number of x1. Here we found out that x2 is the inverse number of x1. So we have two numbers, y1 and x2, that are, both of them are the inverse number of x1. But according to the rule that I mentioned in the beginning of the lecture, we know that every number has only one inverse number. That is to say, x1 has only one inverse number. Therefore, we'll conclude from it that y1 must be equal to x2. Okay, because of the fact that each number, including x1, has only one inverse number, we will conclude from it that y1 equals to x2. Likewise, if we put the second solution to the question, the second solution for x and y will be equal to x2 and y2. If we put this solution inside the question number 3, question number 3 states that x times y equals to 1. So if we put this solution for the question inside the question number 3, that is to say x will be equal to x2 and y will be equal to y2, we will get that x2 times y2 equals to 1. What does it mean? Equation number 3, that x2 times y2 equals to 1. It means that y2 is the inverse number of x2. y2 is the inverse number of x2. But we have already found out that x1 is the inverse number of x2. Here we can write down that x1 is the inverse number of x2. So we found out two numbers, that is to say y2 and x1, that they are the inverse numbers of the same number, that is x2. And according to the rule that every number including x2 has only one inverse number, because of the fact that x2 has only one inverse number, we will conclude from it that y2 is equal to x1. Okay, so we found out that y2 equals to x1, and we have already found out that y1 equals to x2. And now we can write down the answer to the question. We will have two solutions to the question. The first solution to the question will be x1 y1 and we have already found out that x1 equals to square root of 2 plus 1 times square root of 5 minus 1 over 2. This is x1, and we found out that y1 equals to x2. So y1 that equals to x2 will be equal to square root of 2 minus 1 times square root of 5 plus 1 all divided by 2. So this is the first solution to the question, and the second solution to the question is x2 y2. x2 equals to square root of 2 minus 1 times square root of 5 plus 1 over 2. This is x2. And y2, according to what we have already found out, y2 equals to x1. And x1 equals to, or y2 that is actually equals to x1 will be equal to square root of 2 plus 1 times square root of 5 minus 1 divided by 2. So actually those are the two solutions to the question. x1 y1, x1 equals to square root of 2 plus 1 over square root of 5 times square root of 5 minus 1 over 2, and y1 equals to square root of 2 minus 1 times square root of 5 plus 1 over 2. And the second solution to the question is x2 y2, when x2 equals to square root of 2 minus 1 times square root of 5 plus 1 over 2, and y2 equals to square root of 2 plus 1 times square root of 5 minus 1 over 2. Okay? So in the next step I will summarize the lecture. Actually we wanted to find out the values of line segment x and y. We have in the drawing square DEBF. We know that one side of this square is 1 unit, equals to 1 unit. The square is inside the right triangle ABC. The hypotenuse AC of the right triangle ABC equals to 3 units. And we want to find out the values of line segment X, that is FC equals to X, and the value of line segment AD that equals to Y. First of all, we know that the opposite sides of a square are parallel to each other. That is to say, DE is parallel to BF. We know that DE is parallel to BF, and BC is one side of the right triangle ABC, therefore it is absolutely a straight line. So BC is a straight line, and BF is part of the straight line BC, and it is parallel to DE. So if part of the straight line BC is parallel to DE, then the straight line itself BC will be also parallel to DE. Okay, so we found out that BC is parallel to DE, and we have rule number 1 that states that corresponding angles between parallel lines are equal to each other. What does it mean? It means that we have those two angles are defined as corresponding angles, and they are located between the parallel lines DE and BC. That is to say, DE is parallel to BC. Therefore, those two angles are equal to each other. That is to say, angle AED equals to angle ECF according to rule number 1. And if we define angle AED is theta, angle AD equals to theta, then from this equation we will derive that angle ECF also equals to theta. So this angle ECF also equals to theta. Then I presented to you rule number 2. According to rule number 2, the sum of the angles on one side of a straight line is equal to 180 degrees. So here we have AB is one side of the right triangle, triangle ABC, therefore it is absolutely a straight line. Okay, so AB is a straight line, and if you focus on this side of the straight line AB at point D, then the sum of the angles must be equal to, at point D, the sum of the angles must be equal to 180 degrees. So this angle that we defined as angle X plus this angle that is 90 degrees, in total the sum of those two angles must be equal to 180 degrees. That is to say, X plus 90 degrees must be equal to 180 degrees according to rule number 2. Here we subtracted 90 degrees from this equation and we found out that angle X equals to 90 degrees. So this angle is a right angle, it equals to 90 degrees. Likewise, we know that BC is one side of the right triangle, triangle ABC, therefore it is absolutely a straight line. BC is a straight line. So if we focus on the upper side of the straight line BC at point F, then the sum of the angles must be equal to 180 degrees. So if we define this angle as angle Y plus this angle that equals to 90 degrees, in total the sum of those two angles must be equal to 180 degrees. That is to say, angle Y plus 90 degrees must be equal to 180 degrees according to rule number 2. We subtracted 90 degrees from this equation and we found out that angle Y equals to 180 degrees minus 90 degrees. That is to say, it equals to 90 degrees. So angle Y is a right angle. So this angle is equal to 90 degrees. Then we focused on the right triangle, triangle AED. In the right triangle, triangle AED, tangens theta equals to AD over DE. Tangens theta in the right triangle AED equals to AD over ED. AD equals to Y and DE equals to 1. So in conclusion, we found out that according to equation number 1, tangens theta equals to Y. Then we focused on the right triangle, triangle ECF. This right triangle, here tangens theta equals to EF over FC. In the right triangle, triangle ECF, tangens theta equals to EF over FC. But EF equals to 1, FC equals to X. So in conclusion, we found out that in the right triangle, triangle EFC, according to equation number 2, tangens theta equals to 1 over X. Then we created the equation number 3 that states that tangens theta according to equation number 1 it must be equal to tangens theta according to equation number 2. That is to say, tangens theta according to equation number 1 that equals to Y must be equal to tangens theta according to equation number 2 that equals to 1 over X. In conclusion, we found out that according to equation number 3, Y equals to 1 over X. We multiplied the equation number 3 by X. And we found out that Y times X equals to 1. Y times X equals to 1 according to equation number 3. What does it mean? It means that X is the inverse number of Y and Y is the inverse number of X. And we also have the rule that says that every number has only one inverse number. Okay, every number has only one inverse number. The inverse number of 5 is 1 over 5 and only 1 over 5, and the inverse number of 1 over 5 is 5 and only 5. Okay, then we focus on the right triangle, triangle ABC. According to the Pythagoras theorem, in the right triangle, triangle ABC, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, the square of the hypotenuse is AC squared and it equals to the sum of the squares of the perpendiculars. That is to say, it equals to AB squared plus BC squared. I repeat again, the right triangle, triangle ABC according to equation number 4 And Pythagoras theorem, AC squared equals to AB squared plus BC squared. AC equals to 3 units, therefore AC squared is 3 squared, 3 squared is 9. AB equals to y plus 1, so AB squared is y plus 1 squared. BC equals to x plus 1, so BC squared is x plus 1 squared. So in conclusion, we found out that according to equation number 4, 9 equals to y plus 1 squared plus x plus 1 squared. Here we open the brackets on this side of equation number 4 and we found out that y plus 1 squared equals to y squared plus 2y plus 1 plus x plus 1 squared. X plus 1 squared equals to x plus 1 squared equals to x squared plus 2x plus 1. And in the other side of the equation we have 9, so it equals to 9. But according to equation number 3, y equals to 1 over x. So we can substitute y in this equation number 4, by 1 over x. We did it and we got that y squared equals to 1 over x squared plus 2y is 2 over x plus 1 plus x squared plus 2x plus 1 equals to 9. Here we organize the expressions in a different way and we got that in equation number 4, x squared plus 1 over x plus 2 plus 2x plus 2 over x equals to 9. So in the brackets, x squared plus 1 over x squared plus 2, this expression equals to x plus 1 over x squared. So we can substitute this expression by x plus 1 over x squared. We did it. And here, from those two expressions, we took 2 as a common factor, and inside the brackets we have x plus 1 over x, that equals to 9. Here we defined x plus 1 over x as t, that is to say t equals to x plus 1 over x according to our definition. And now we can substitute x plus 1 over x by d, and we got here that this expression equals to t squared. Here we have plus 2t, we subtracted 9, so it is minus 9 equals to 0. So here we have a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. Here a, b and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. We will find out the value of x according to the following formula, that x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. In our specific quadratic equation, the variable that we are looking for is t, so x equals to t, a equals to 1, t equals to 2, and c equals to minus 9. So we put the data inside the formula for x, and we found out that x equals to 2t, so it is actually t equals to minus b, b equals to 2, so minus b is minus 2, plus minus b squared, b is 2, so b squared is 2 squared, 2 squared is 4, minus 4 times a times c. This is actually minus 4 times a is 1, and c is minus 9, so it is actually minus 4 times minus 9, that is 36, all divided by 2. 4 plus 36 is 40, so in conclusion we found out that t equals to minus 2 plus minus square root of 40 over 2. Square root of 40 is 4 times 10, and square root of 4 is 2, so in conclusion we found out that t equals to minus 2 plus minus 2 times square root of 10 over 2. And here minus 2 over 2 is minus 1, and 2 over 2 is 1, so in conclusion we found out that t equals to minus 1 plus minus square root of 10. So we have here two solutions that are possible for t. The first solution is that t equals to minus 1 plus square root of 10, and the second solution is t equals to minus 1 minus square root of 10. We focus on the second solution. The second solution is t equals to minus 1 minus square root of 10, and according to our definition, t equals to x plus 1 over x. So we substitute the t by x plus 1 over x, and it must be equal to minus 1 minus square root of 10. But x is the length of one side of the right triangle EFC. Therefore, it must be a positive number. If x is positive number, then x plus 1 over x is also a positive number. So in this side of the equation, we have a positive number, and it must be equal to this expression that is actually minus 1 minus square root of 10. But minus 1 minus square root of 10 is a negative number, and a positive number can never be equal to a negative number. So we got to a contradiction. Therefore, this solution is incorrect solution. We cancel this solution, and we left only with the solution that t equals to minus 1 plus square root of 10. Okay, so we found out that the solution for t is t equals to minus 1 pi plus square root of 10, and t according to our definition is x plus 1 over x, and it equals to minus 1 plus square root of 10. Here we multiplied x by x, and then we divide it by x in order to have a common factor with 1 over x, and we got that x squared plus 1 over x equals to minus 1 plus square root of 10. Here we multiplied this equation by x, and we found out that x squared plus 1 equals to square root of 10 minus 1 times x. Here we subtracted square root of 10 minus 1 times x from this equation, and we got a quadratic equation that x squared minus square root of 10 minus 1 times x plus 1 equals to 0. In this quadratic equation, a equals to 1, b equals to minus square root of 10 minus 1, and c equals to 1. And the general solution for a quadratic equation is the formula that x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. In our specific quadratic equation, x will be equal to minus b, and b is minus square root of 10 minus 1, so minus b is minus minus, minus minus is plus, so in conclusion we got that b equals to square root of 10 minus 1 plus minus b squared. B squared is square root of 10 minus 1 squared, minus 4 times ac is minus 4 over 2. So we got that x equals to square root of 10 minus 1 plus minus square root of 10 minus 1 squared is, we calculated the value of this expression according to the formula that a minus b squared equals to a squared plus b squared minus 2 times ab. So a is square root of 10, and a squared is square root of 10 squared. Square root of 10 squared is 10 plus b squared. B is 1, so b squared is 1 squared. 1 squared is 1, minus 2 times square root of 10, that is minus 2ab, minus 4, 1 divided by 2. So x equals to square root of 10 minus 1 plus minus. Here 10 plus 1 is 11, and 11 minus 4 is 7. So inside the brackets, inside the root, we have square root of 7 minus 2 times square root of 10. And then we found out the value of 7. Actually, we presented the expression that is inside the root, that is 7 minus 2 times square root of 10, in a different way. 7 is 5 plus 2, and 2 times square root of 2 is 2 times square root of 5 times square root of 2, because of the fact that square root of 5 times square root of 2 is square root of 10. So, in conclusion, we found out that 7 minus 2 times square root of 10 equals to 5 plus 2 minus 2 times square root of 5 times square root of 2. Here we substituted 5 by square root of 5 square, and we substituted 2 by square root of 2 square. And then in conclusion, we found out that square root of 5 square plus square root of 2 square minus 2 times square root of 5 times square root of 2 equals 2. This expression is very similar to the algebraic identity that states that a square plus b square minus 2 times ab equals to a minus b square. Here a equals to square root of 5 and b equals to square root of 2. Therefore a minus b square will be equal to square root of 5 minus square root of 2 square. So we substituted this expression by square root of 5 minus square root of 2 square. And then we put, so we actually, according to this expression, we can substitute 7 minus 2 times square root of 10 by square root of 5 minus square root of 2 square, because they are equal to each other. We did it, and we got that x equals to square root of 10 minus 1 plus minus, and again we substituted 7 minus 2 times square root of 10 by square root of 5 minus square root of 2 square, all divided by 2. Here we have the square cancels the root, and we left only with square root of 5 minus square root of 2. So in conclusion, we got that x equals to square root of 10 minus 1 plus minus square root of 5 minus square root of 2 over 2. And we have here two solutions that are possible for x. The first solution is x1 equals to square root of 10 minus 1 plus square root of 5 minus square root of 2, and the second solution for x, for this quadratic equation, is x2, that equals to square root of 10 minus 1 minus square root of 5 minus square root of 2. So we continue with x1. Here we substituted square root of 10 by square root of 5 times square root of 2, and we got that x1 equals to square root of 5 times square root of 2 minus 1 plus square root of 5 minus square root of 2 over 2. Here we took square root of 5 as a common factor of this expression, and we got that x1 equals to square root of 5, and inside the brackets we have square root of 2 plus square root of 2 plus 1 minus, here we took minus 1 as a common factor, and inside the brackets we have square root of 2 plus 1, all divided by 2. Then we took square root of 2 plus 1 as a common factor out of these expressions, and we found out that x1, in conclusion, x1 equals to square root of 2 plus 1 times square root of 5 minus 1 over 2. We did the same process for x2. So here x2 equals to square root of 10 minus 1 minus square root of 5 minus square root of 2. So x2 equals to, here we substituted square root of 10 by square root of 5 times square root of 2, and we got that x2 equals to square root of 5 times square root of 2 minus 1 minus square root of 5. Here we have minus and minus is plus, so it is plus square root of 2, all divided by 2. Here we took square root of 5 as a common factor out of this expression, and we got that x2 equals to square root of 5, and inside the brackets we have here square root of 2 minus 1 plus square root of 2 minus 1. Here we took square root of 2 minus 1 as a common factor, and we got that x2 equals to square root of 2 minus 1 is a common factor, and inside the brackets we have square root of 5 plus square root of 5 plus 1 over 2. So in conclusion, x2 equals to square root of 2 minus 1 times square root of 5 plus 1 over 2. This is the value of x2. So then we multiplied x1 by x2. So I copied x1 and x2 in this page, and then we multiplied x1 by x2. Then I organized the expressions here in a different way, and we found out that x1 times x2 equals to square root of 2 plus 1 times square root of 2 minus 1 times square root of 5 plus 1 times square root of 5 minus 1, all divided by 2 times 2. Then we calculated the value of square root of 2 times square root of 2 plus 1 times square root of 2 minus 1, according to the algebraic identity that states that a plus b times a minus b equals to a squared minus b squared. So this expression is equal to a squared plus b squared, and according to this algebraic identity, a plus b times a minus b equals to a squared minus b squared. In our specific expression, a equals to square root of 2 and b equals to 1. So we must get here that the value of this expression, according to this algebraic identity, equals to a squared minus b squared. A equals to square root of 2. So a squared is square root of 2 squared. Square root of 2 squared is 2. Minus b squared. B equals to 1. So b squared is 1 squared. 1 squared is 1. So in conclusion, we found out that a squared minus b squared, it is actually 2 minus 1. So in conclusion, square root of 2 plus 1 times square root of 2 minus 1 equals to 2 minus 1, that is actually 1. Then we found out the value of the expression square root of 5 plus 1 times square root of 5 minus 1. Here, according to the algebraic identity, the value of this expression must be equal to a squared minus b squared. In our specific expression, a equals to square root of 5 and b equals to 1. So a squared will be equal to square root of 5 squared, that is actually 5, minus b squared, that is 1 squared, is 1. So in conclusion, we found out that a squared minus b squared, it is actually 5 minus 1. Okay? So in conclusion, x1 times x2 equals to 2 minus 1 times 5 minus 1 over 2 times 2. 2 minus 1 is 1, 5 minus 1 is 4, all divided by 2 times 2, that is 4. 1 times 4 is 4, and 4 over 4 is 1. So in conclusion, we found out that x1 times x2 equals to 1. Okay, x1 times x2 equals to 1. What does it mean that x1 times x2 equals to 1? It means that x1 is the inverse number of x2, and x2 is the inverse number of x1. And also, according to equation number 3, we've already found out that x times y equals to 1. And if we put the solutions of our problem in equation number 3, we have two solutions that are possible. x1 and y1 is the first solution for x and y, and the second solution for x and y is x2 and y2. So we put the first solution in equation number 3, that is to say x equals to x1 and y equals to y1, and we got equation number 3 that states that x1 times y1 equals to 1. What does it mean? It means that y1 is the inverse number of x1. But we have already found out that x2 is the inverse number of x1. So we have two inverse numbers for x1. But according to the rule that every number has only one inverse number, it means that y1 must be equal to x2. Because of the fact that x1 has only one inverse number, we conclude from it that y1 equals to x2. Okay, likewise, then we put the second solution to the question. The second solution to the question is x2, y2. So we put the solution inside the equation number 3, that is to say x equals to x2 and y equals to y2. And we got equation number 3 that states that x2 times y2 equals to 1. What does it mean? It means that y2 is the inverse number of x2. Okay, from one side, but we have already found out that x1 is the inverse number of x2. And according to the rule that each number has only one inverse number, so therefore the two numbers y2 and x1 must be equal to each other, because of the rule that each number has only one inverse number. So the two numbers y2 and x1 must be equal to each other, according to the rule that every number has only one inverse number. Therefore y2 must be equal to x1, and we have already found out that y1 equals to x2. So the solution to the question is, we have two solutions. The first solution is x1, y1. x1 equals to square root of 2 plus 1 times square root of 5 minus 1 over 2. And we have already found out that y1 equals to x2. So that is to say it equals to square root of 2 minus 1 times square root of 5 plus 1 over 2. And the second solution to the question is x2, y2. x2 equals to square root of 2 minus 1 times square root of 5 plus 1 over 2. And we have already found out that y2 equals to y1. That is to say, y2 equals to square root of 2 plus 1 times square root of 5 minus 1 over 2. So those are the two solutions for x and y. Okay, thank you very much.